Hello everyone. In this video I am going to demonstrate PWM output voltage control on TL494 IC based SMPS. My SMPS input is 12 volts AC and output is 220 volts AC at 20 watt. My operating frequency is 63 kilohertz. As you can see here, this is the setup. You can see here, this is the power switch and here are the heat sinks. Here is one power switch, here is another power switch. Here comes the TL494 IC. TL494 is working in push-pull mode. Here you can see this is the circuit made on a breadboard. Here you can see this potentiometer is used for the PWM feedback, and this is how the basic setup looks like. This is my transformer generating 20 watts of power, and you can see here this is the load lamp. This is the load lamp. Here comes my oscilloscope. This is the complete setup. So now let me describe the circuit diagram. As you can see here, this is the circuit diagram. This is the TL494 IC. Here you can see pin number 8 is output and pin number 11 is output. This pin number 11 is going to one IGBT gate and pin number 8 is going to another IGBT gate. So here you can see this is the feedback loop. You can see here from the pin number 13, I have taken supply voltage of 5 volts, and here comes the voltage divider network, and from here the PWM output voltage is fed to the pin number 3. This is how I have made the PWM control. So here you can see from pin number 8, and here you can see from pin number 11 signals are coming, and there is a pull-up resistance of 330 ohms 1 watt, pull to plus VCC is 12 volts DC plus VCC. So my plus VCC is 12 volts DC, and here you can see this is 100 ohms current limiting resistance and a 10k resistance here connected to the ground. This resistance is used to discharge the gate capacitance of the IGBT. I am using 25 and 120 IGBT. So both the IGBTs are of same numbers. So here you can see this is my transformer. This is the transformer. This is center tapped transformer. You can see this is basically a bifilar winding in the primary. Here you can see, and here is the pull-up voltage of 12 volts, center tap voltage of plus 12 volts, and here comes the load lamp. So this is the basic setup. So now I am going to demonstrate the responses that I have recorded. My supply voltage is 12 volts DC. You can see here my supply voltage is 12 volts DC. Voltage on IGBT1 drain or the transformer input is 9.5 volts AC to 6.5 volts AC PWM. The second IGBT is also having the same results, and the transformer secondary voltage is between 220 volts AC to 158 volts AC PWM. You can see the frequency of operation is 63 kilohertz, and the duty cycle doesn't matter because I am using a PWM control. And here you can see pin number 3 feedback voltage is between 0.851 volts to 2.27 volts DC. Here you can see this is the pin number 3 of the IC. This is the PWM input pin. This is the feedback pin basically. So here I am giving the feedback voltage between 0.8 to 2.27 volts, and we are getting a secondary voltage in the transformer between 220 volts AC to 158 volts AC. I am going to demonstrate the results first, then I am going to demonstrate the circuit along with the PWM response. So here you can see this is the pin number 3 voltage. This is the feedback of the TL494 IC, and this is the output voltage on the transformer. When the voltage is 0.851 volts DC, output is 220 volts AC. I am increasing this voltage. You can see 1.012. It is 219 volts, 1.40, 202, 1.8, 1.60. It is 192 volts, 1.76, 184. So you can see like this, when I am increasing the voltage on the feedback, the output voltage on the transformer is decreasing. You can see, and when the output voltage on transformer is 158 volts AC, you can see the primary voltage of the transformer is 6.5 volts AC on the IGBT gate basically, and on the IGBT gate it is 9.5 volts AC when the voltage is 220 volts AC. Let me power up the circuit now. I am powering up the circuit. You can see here the lamp is glowing. You can see. You can see here this is the PWM voltage on the oscilloscope. See, this is the voltage on the transformer secondary, 152 volts AC. Rating frequency is 63 kilohertz. Now I am going to adjust this potentiometer, and I am going to get the PWM output. Now I am going to change the voltage on the PWM pin. Let's see the response. You can see. You can see the time period of the gate firing is changing. Just a minute, I have switched off. Again I have switched it on. You can see the time period of the gate firing. Carefully, if you can see, it is changing. So here you can see this is the setup. The load lamp is glowing. The supply voltage is 12.24 volt DC. Voltage on the transformer primary is 9.26 volts AC. Output voltage is 210 volts AC. And the load current is, the multimeter is not able to measure it. So this is how the setup looks like. So like this we can adjust the PWM input. You can see here this PWM with a potentiometer or with a fixed feedback, we can adjust the PWM signal and we can control an SMPS. So this is how we can use the PWM option of TL494 IC and control a power supply. Thanks a lot. Thanks for watching. I am going to add all the necessary design files in the description link. Thank you.